Hello again guys, welcome to another session of Shomu's Biology presents Biology Math Problems, and let's talk about another very intriguing problem and very realistic one. So let's deal with this problem over here. That's a growth rate regarding problem, and we have solved some of the problems previously. So let's do it this time. The question is, a hypothetical population has a carrying capacity of 1500. Let me change the color, 1500 individuals, and the R max is 1. Now fill the following table, and they have provided us with the population size, as well as they want us to calculate the population growth rate over time. And second question is, what is happening to the population according to looking at this population growth rate compared to the population size, and why that thing is happening. So let's do this problem and let's solve this problem. So actually, for solving any growth rate regarding problem containing carrying capacity and R max, there is one particular formula for that, and formula is for the logistic growth. Remember, logistic growth. Why we are talking about logistic growth? Because that's the only type of growth that is generally possible in population. Because there are two types of growth. One is the exponential growth, where the population is increasing, the number of individuals are increasing with time directly. And another one is where it is increasing after a particular time, it will be stagnant, just like a sigmoidal curve. So this second one, or having the sigmoidal curve, is the example of logistic growth. And the previous one, this one is the this is the exponential growth. So for the logistic growth, there is a calculation for logistic growth rate, and to find out the logistic growth rate, the formula that we deal in all these cases is small d by small n. Actually, so small dn by dt, that's why we form dn by dt equals to r capital N. Now once we know this thing, and we also know that r equals to b minus d right here. So b is for the birth, d is for the death, right? That's how you get r. R means the rate, the growth rate generally, and growth rate equals to dn by dt. That's the general rule over here. So we can write it here, that's dn by dt equals to R max, which is the maximum rate there, multiplied with capital N into 1 minus n divided by k, and that's over. Sorry, the next question pop up there. Anyways, so here it is. This is the formula that we are going to use a lot now, right? So once we know this is the formula, that dn by dt equals to R max n multiplied by 1 minus n by k. Now in this case, capital N stands for, remember what are these things stands for. This is the formula. It's hard to memorize, hard to remember, but once you are dealing with and know all the parameters, it will be easy to calculate. Capital N here is the population number, that is the population number over there, and capital K here is the carrying capacity. If you don't know about what is carrying capacity, what is population, and the basics of population growth, logistic growth, and exponential growth, I recommend you to go back to my YouTube channel and view the population genetics tutorials and population ecological population and population genetics tutorial. I'm sorry. Now once you know those tutorial, you will be understanding all those different terminologies, and that are very, very important for answering the questions like this. So once you know all these things, the value for everything, and these values are already been provided because they have given us the carrying capacity. So let us go back here. So what are the values they provided? They have provided the carrying capacity, and the carrying capacity, or capital K here, is 1500, and the R max is also provided, and that is 1.0, right? And we also have the population size, that is n in all these cases. So let's imagine that's n1, n2, and n3 over time, different duration. So if we know all these things, we can easily calculate for placing the value of n in this equation. We can calculate this rate. So if I calculate it for each of them, for n1, for the first one, for the very first case, it is going to be, remember, so let's put all the values, and the value of R max is 1 multiplied by capital N, in this case carrying capacity 1600, and there is a 1 minus the value for capital N here is the population number, and that is 1600 divided by 1500, because that's the carrying capacity. Remember, 1500. So you put the values there like that, and then we get the answer. Answer is minus 96. Don't worry about the minus values and all these things. It is fine to get the values like that. So in the first place we got minus 96. I've already been calculated all this, so we know. So in the second place, for the second one, putting the value only change in these regions, it is 1750. So if you put those value, we'll get the value on the number minus 298. And for the third one, if we put all the values like 2000, I mean 2000 in this place, what we will get the value of minus 660. So we get all these values, you know, minus 298, minus 660, minus 96, and we are getting these values all the time. So once we get the values, what we can do here, we can simply place them to understand, to get the values. I mean, from here what we can understand. So first question was to figure out all those population growth rate, and that's easily be calculated using the formula, and we have calculated that. For this first one, it is minus 96 that we, so let me change the color here. So it is minus 96. Second one, it is minus 298. And third one, it is minus 660. So you have already calculated that. But looking at that, we can easily conclude over the question, that is what is happening to the population. Now what we can see here, that the population growth rate is, you know, it's kind of decreasing over the time. As you can see, the negative value, this is increasing. Negative value is increasing means it's decreasing. The growth rate is decreasing, and you can see that so growth rate is decreasing, and the population size is now 2000 individuals, where the carrying capacity is 1500. Now remember the carrying capacity value. Carrying capacity is the particular number of individual for a population for the environment to hold. I mean, more than that number will collapse the population, right? And that's what happening here, because the carrying capacity is 1500. That means that particular population, that particular environment can hold up to 1500 individuals at a time, I mean at max. But now it's exceeding towards 2000. That means, and also as the population growth rate is down, that means we know the meaning is that population is shrinking, because the population size is exceeding the carrying capacity. So actually by solving this problem, we can get a very basic fundamental principle of the population. That is, if the population size is increasing, so if the population size, that is capital N, is greater than the carrying capacity, then the population will shrink. Population will shrink. Remember, let me write it with red. The population will shrink. And that's what's happening in this case, right? So that's it, guys. Thank you very much for listening.